Okay, you ready for this? This is the last example in the integration chapter. The last one. It's kind of exciting and a little bit emotional at the same time, don't you think? It also means it's the very last example we're going to work through in Pure Book 2. Wow. It's like coming to the end of the road almost, isn't it? Okay, so it's really, really exciting and powerful stuff. Okay, should we do this? Yeah, let's do this. Now, it's a fairly long example. I don't know if I'm going to fit it into one video. Sometimes I do one example per video, just so that it's not too long for the upload speed or download speed, whichever way it is. But this one, depending on how long it goes, I might just break it up. I'm going to see. I'm going to see. Okay. Do you like my little picture there? Just so I didn't have a blank board there. Anyway, let's have a look. Okay. Now, with these questions, you've really got to keep on reading the question, reading the information. I'm going to have to refer to it a lot just to make sure that I'm not missing bits out, because there's an awful lot going on in here. Okay. But it is, as I was wishing for, a more challenging example. Okay. It's a lovely example. Okay. Now, water in a manufacturing plant is held in a large cylindrical tank, diameter 20 metres. There it is, so tank 20 metres. Water flows out of the bottom of the tank through a tap at a rate proportional to the cube root of the volume. Show that t minutes after the tap is opened, dH dt is negative k cube root of h for some constant k. So this part A question is the sort of thing you'd have got in the differentiation chapter. Remember I referred to that a couple of videos ago, or even last video? The differentiation chapter is about setting up a differential equation. So there's no integration yet, okay? We just got to set up this differential equation, okay? Now, what I'm going to do is, I'm just going to write down some information that's going to help us with that, okay? So we want to show that, so let's write it down here, shall we? Show that dH dt is equal to negative k cube root of h, okay? For some value of k you need to find, all right? And what else do we know? Water flows out at the bottom of the tank through a rate which is proportional to the cube root of the volume. Okay, so water flowing out of a tank, that is dV dt. Remember, rate of change of volume with respect to time. Water's flowing out, and it's a rate proportional, so it's negative k. Okay. Oh, hang on, just a minute. Good job I wrote that down, see, isn't it? Because we're going to want to end up with k there, and I really don't think that k there is going to be the same as that k there. So I'm going to choose that to be something different. Okay, I'm going to choose that to be. So shall I be consistent with the book? What do they go for? They must have it somewhere. Yeah, they went for C. Okay, so I'm going to call it C as well, just in case you're reading the example as well, just to make sure that it matches up and stuff. Okay, so let's read the question again. Water flows out at a rate proportional to the cube root of the volume. So that's the cube root of the volume, isn't it? Okay, so that's, it's that. Okay, right, next. Well, when we see that this here is not in terms of V, is it? So we're going to need to work out what the volume is. Okay, that's kind of why this is here. So do you remember the volume for a cylinder? It's pi r squared h. Okay, and radius is 10. There's all sorts of places where you can make mistakes here, so just imagine you put in radius as 20. That's it, the rest of the question gone. Okay, you'll get method marks and stuff, but you'll lose quite a lot of accuracy marks because it won't be correct. So radius is, let's just write that down, shall we? R equals 10 meters, of course, so you're going to have 10 squared as 100, so that's going to be 100 pi h, which is looking nicer because we want our answer to be in terms of numbers and h, don't we? We don't want r at all. Okay, so that's fine, 100 pi h. So we can put that in there if we want, straight away. But for the moment, just got to hang on to it, because what we need to get is dH dt. Now, do you remember how to do these? You need to use the chain rule to do it. Okay, so dH dt, now we've got dV dt, okay? And what that means is we're going to have to multiply that by something to get dH dt. Obviously we need the h on top, dH, and we're going to have the dv's cancelling, aren't we? Yeah, so there we go. We're going to have that, aren't we? Yeah, makes sense? So you've got dH dt left there, okay? So the dv dt is going to be equal to that, negative c cube root of v. You've got to be careful. Got to be careful that I don't read that as c cubed. Okay, so cube root of v. Okay, and dh dv. We don't have that, do we? So we're going to have to get it from here, aren't we? So if v is equal to 100 pi h, dv dh is equal to 100 pi. That's nice and simple. Yeah. So that means dh dv is going to be equal to the reciprocal of that. Yeah. So reciprocal of that is going to be over 100 pi. We're okay with that? Let's just put the equals sign there because it looks a bit nicer. Okay. So that's our expression for dh dt. All right. So we've got dh dt is equal to. And is it looking something like this yet? Well, nearly. Okay. Because the c, the 100, the pi, all of that can be combined in terms of k. So we're not worried about the numbers. All right. But the v, we need to just sort that out, don't we? So cube root of v, so what we're looking for is the cube root of that, aren't we? Okay, the cube root of that. So that's going to be negative c, and then cube root of that, 100 pi h over 100 pi. Yeah. Is it fine just to write down that line next, do you think? What do you think? Okay. I think it is, because you've got the cube root of h there, yeah, which is that. And then all the rest are just numbers, constants. So you get c, which is a constant, cube root of 100 pi, which is a constant, over 100 pi. Yeah, I'm sure you could simplify that, but yeah, that's fine. Does the question state that k has to be written down? Because sometimes it says, show that it's in this form where k is a constant to be stated. It doesn't, does it? It says for some constant k. Yes. Which means you don't have to. Okay. Just check the work in the book if you want. They kind of write down that constant is. I'll just check that as well. So c cube root 100 pi over 100. Yeah, that's fine. Okay. So yeah, we're happy with that. Yeah, you happy with that? I'm so glad. So glad you said yes. Right, because I've had some issues with recording recently. I'm just going to check every now and again to make sure it is still recording. Okay. Part B, I need to know which bits to keep. Okay, because I might need to see it again. Show that the general solution to the differential equation may be written as right. So what that means is we have to solve this differential equation, isn't it? Okay. Now, be careful. Okay, because I could potentially see some of you trying to put this into it and solving this. That's going to be nasty. Don't do that. Doable, yes. Okay, it's A-level, year 13s. Doable, but no. If we don't really need to know all of this, if we can put it in terms of k, do that. Okay. And I noticed in some of the past papers, some of you were sort of putting this in rather than just keeping it simple. Try and keep it simple as much as you can. You know what? I mean, one of the challenges of I say maths in general, not just A-level maths, but year 7, year 13, university maths. One of the challenges in general is to make sure you focus on what is really important, okay, and try and keep things simple, not overcomplicate things, okay. So what I'm saying is, no, just start with that, okay. Don't overcomplicate things. You don't need to have the rest of it, okay. That's the same with life in general, isn't it? If you can just focus on what is, simplest, and don't overcomplicate things, because people have a tendency to overcomplicate, don't they? dht is equal to negative k, and then cube root of h. Yeah, you've got to be careful of that. It's cube root of h, isn't it? Not k cubed. Yeah. So look, I'm going to start off with that, and this is where I'm going to do my solution to the next part of the question. Okay. Maybe I'll stop the video there, okay? Just because it's kind of a long question, and maybe you'll have a little break, okay? And I just want to make sure that the upload speed doesn't take too long, okay? So stand by. I'm about to do this bit next, okay? All right. There we go. It was literally just 2 seconds, okay? Right, part B. I didn't even read it in my break. Okay, I just press the button and press it again. Okay, so show that the general solution to this differential equation may be written as, I'm going to write that down. Okay, because it's always a good idea to write down what you're trying to get to. P minus Q T. It's looking awkward, isn't it? Because they've put K in there, put P there, Q there. There's, almost every letter of the alphabet they're trying to find here. Okay, so it's power 3 over 2. So I've written that right. H equals P minus QT to the power 3 over 2. Yeah, P and Q are constants. Yeah. Show the general solution to the differential equation written as this. Right, before I start, it doesn't tell us to write down what P and Q are, which is great. So remember that awkward expression in terms of K? I can't even remember what it was. It involved C, it involved 100, pi, Q roots, didn't it? As far as the question is concerned, I think we can forget about that. I've not read the rest of the question, but I think we can forget about that unless called upon to use it. But I think we can just assume that we're not going to need that anymore. Okay, so solve this means get an expression for H in terms of K. Sorry, H in terms of T. Okay, because it's dH dt. So we'll separate the variables, so we'll bring that onto that side. Okay, so that's going to be, I'll tell you what, let's write it as 1 over cube root of H, like that, shall we? Yeah, and then keep the negative K. As I've said before on these videos, keep that there. There's no point in swapping that around, okay? So that's going to be dH there, and then you've got the equals, and that's negative K, and that's dt there. Okay with that? So put that over there with the dH, 1 over cube root of H dH, and then equals, keep that there, put the dt there, so that's that, okay? And then we just integrate that, okay? So this here, that's quite simple, isn't it? Let's just write it as h to the power of negative 1/3, shall we? dH, and that's, well, I think we can just do that straight away, can't we? That's equal to negative kt. Oh, what letters should we use this time? Well, I've used C, I've used K. We're running out of letters, aren't we? I could use C1 or C2. I'm going to be consistent though. I'm going to see if the textbook has used something that, oh dear, I don't like that. They've used C. Oh dear, no, I don't like that. Well, I'm not going to use C because mathematically it doesn't follow, because that C is not necessarily going to be the same C we had earlier, is it? No. So, well, what letter would you like to use? Okay, here's your one chance to sort of say, come on, use the force, give me a letter. What letter do you want to use? D. I heard D. Okay. Right. Comes after C. I imagine that's the reason why. Okay. So yeah, let's integrate this, shall we? So h to the power of 2/3 multiplied by 3 over 2. Just check that, 2/3 times that, yeah, h to the power of negative a third. And that's equal to negative kt plus d. Yeah, I might have a kt in the class, do I? Negative kt. I've got tan A, of course. Yeah, but negative kt. Yeah, I don't have a kt. Or Catherine, because sometimes Kate is short for Catherine. Anyway, there you go. Yeah, I've been saying KT for years, but I've never had a KT in my class. Isn't that amazing? Isn't that amazing? Otherwise, I would have said it. I'd have said it. Okay. Anyway, where was that? We need to get that. Ooh. Yeah, we need to get that. Okay. Well, little steps. Okay. Multiply by 2, divide by 3. Yeah. So that's going to be negative 2/3 of KT. Sorry. 2/3 D. Okay, so you happy with that? And then I think we should be able to just, I almost forgot 2/3. I think of Katie on that. There was no Katie. Just being silly on that. Yeah, so we want to get H on its own, so we're going to raise this side to the power of 3 over 2, don't we? So negative 2/3, right, KT, let's be sensible, plus 2/3 D, all to the power of 3 over 2. Okay. Is that the same as this? Can we just write down this line there? What do you think? Okay. So the negative 2/3 K, yeah, that's just a constant, so we can call that the negative Q, can't we? So I'm happy with that. 2/3 D, yeah, that's a constant. call that P. Yeah, that's it. Okay, and just check the question again. No, it doesn't say we have to write down what these constants actually are. So we're fine with that. Okay, we're fine with that. All good? Great. I'm just going to check the recording again. Hey. Yeah, I'm glad I stopped that because it's taken a long time, this example. It's a lovely, lovely example. It's quite nice. Okay, it's not my favourite, has to be said, but it's alright. I'll probably know by now what my favourites are. They're the ones that include all the graphs, you know, and all the integration and the calculus in there as well. All of that, those are my favourites. Okay. This, to be honest, involves just a little bit of integration. That was my favourite bit. Yeah, the rest of it, modelling to the real world. Yeah, that's alright, it's nice. How do you feel about modelling? They're alright, aren't they? But it's like, do you know what I mean? It's no longer pure maths. That's my thing. I love pure maths. Okay, I like doing the maths. I don't necessarily like applying it to the real world. I find it interesting. Yeah, I look at the real world when I'm walking around and I can see the mathematics there, but I don't find the applying maths to the real world as interesting. Okay, I love mechanics. Yeah, great. I like the mathematics of it. I like drawing the inclined planes, and I like setting up the equations and solving it. Actual applying bit, I can do that. I don't really need all that. Okay. Yeah, I'm more of a purist, to be honest, and it's no coincidence that my mathematics degree was in pure mathematics. I didn't do any what you might call hardcore applying mathematics. Yeah, there's some applied mathematics in there, but most of it was sort of pure stuff. Okay, so I'm kind of proud of that. It also explains why I love doing all this stuff as well. That's why I like a good graph. You know, that's why I like doing all the integration work. You know, the ones who do degrees in pure mathematics, maybe like me. The ones who do it in, you know, applied mathematics, maybe they do prefer the mechanics, or, you know, some people prefer statistics. I know, yeah. That's what I think as well. But statistics are still better than most other subjects, because it's still a branch of mathematics, isn't it? But, you know, pure maths, statistics, yeah. Yeah, it's like, you know, a large chocolate bar or tomato. Come on, what you could choose? Pure maths or statistics? Come on. Seriously. Yeah. Even if you're on a diet, you'll go for the chocolate bar, aren't you? Yeah. Even if you don't like chocolate, you'll go for the chocolate bar, because it just, yeah. Yeah, so anyway, there you go. Right, so enough of that. Let's read what the question was, okay? So we've done that. That's the general solution. Initially, let's write it down. Initially, t equals 0. That's what initially means, isn't it? Initially, the height of the water is 27 metres. H equals 27. I like the number 27. And 10 minutes later, okay, the height is 8 metres. And what's the time measured in? T minutes. You'll be careful with that, because if it says, you know, the time is T hours, then it says 10 minutes later. That's why you'll reread the question, because sometimes, you know, they catch you out. Okay, so 10 minutes later, all right, so when T equals 10, the height is 8 metres. All right, okay, that. Good. Find the values of the constants of P and Q. Okay, again, I'm going to mention something about not complicating things. Use this. Do not go back to the K we had before. Do not go back to the C and the root 100 and the cube root pi and all that. Use this, okay? Let's just substitute in, okay? This is always the one you want to do first. T is equal to 0, okay? So you've got 27 is equal to 0p to the power 3 over 2. Okay, done. Keep that in your head? I really hope so, okay? So cube root of 27 is 3, and then square it, you get 9. Okay, so p is equal to 9. Hope you're happy with that. And if you're in doubt, just do 9 to the power of half is 3, and then cube it is 27. Okay, so that's that. Okay, so maybe I'll just write down our new expression, our new equation, 9 subtract qt to the power of 3 over 2. Okay. Next, t is equal to 10, okay, and h equals 8. So you're going to have 8 equals 9 minus 10q to the power of 3 over 2. Okay, these numbers are quite nice, aren't they? Because look, you can do cube root of both sides and then square both sides, aren't we? So when you do 8 cube root of that is 2 and square that is 4. So you've got 4 is equal to 9 minus 10q. Happy with that? I hope you're happy with that. Okay. And then what are we going to do? 10q is equal to 5. Q is equal to 1/2. Okay. So yeah, that was from before, wasn't it? Don't really need that. What do the questions say? Find out what P and Q are? Yeah, I've done that, but let's just write a good therefore. We all love a good therefore symbol, don't we? Yeah. H is equal to 9 minus 1/2 T 3 over 2. Are you still writing fractions? I really hope so. In my absence, I really hope, the things I've been recommending all this time, like you're saying natural log, even in your head you're doing it, okay, and you're writing things as fractions. It's just, I really hope you're doing it. It'll please me a lot if you're doing all that, okay. Let's just check that we're good with that. Yeah, so in the textbook you see they kind of do all that and they kind of write, Q equals 1/2 and P equals 9, but they don't actually. It's better to do that, isn't it? They probably do it for the next page, part D. Yeah, H equals 9 minus 1/2 T to the power of 3 over 2. Yeah. Part D, the final part of the final example. Yeah. Find the time in minutes when the water is at a depth of 1 metre. Okay, let's not push the boat out. Let's not make it a really hard question, shall we? Fine, because it's. Why don't I just start this up here again? Because I don't know, you never know. I might need a little bit of board space to do it. Well, no, let's say it again. I will need more board space to do it, won't I? Because I'm not going to fit it in there, to be honest. So H equals 9 minus 1/2 T to the power of 3 over 2. Okay, there we go. So, there we go, and I've forgotten the question. Okay. Yeah, so find the time in minutes when the water is at a depth of 1 metre. Okay, so water depth of 1 metre. Okay, so 1 is equal to 9 minus 1/2 T to the power of 3 over 2. Oh, come on. 1, really? Cube root of 1, square 1. Yeah, it's just 9 minus 1/2 T. Could be any easier. Okay, so 1/2 T is equal to 9 minus 1, which is 8. T is equal to 16 minutes. Yeah. Let's just check that it was T in terms of minutes. Yeah, T minutes. Okay. Yeah, so that's it. Yeah, that is the question. Let's make sure I've got all that. Alright, sorry, I had technical difficulties. They've been plaguing me a little bit, as I mentioned before, okay? But I mean, it's kind of almost towards the end anyway, so that was it. I did get through to the end of it and there wasn't really much else to say. It's just, to be honest, I didn't really want to leave it on the video cutting out, okay, without just saying a couple more words about it. So, yeah, that was it. I'm just sorry that there's nothing more interesting that's on the board for the final example of the Year 2 book, okay? Seems like a bit of a milestone, sort of done. This is it. Okay, I'd rather have had a lovely graph of some sort with some really good hardcore integral stuff in there, but no, it's just this, okay, it's just that, okay. Yeah, I'm sure this isn't the last video from me, of course, because I'll post some more, yeah. But yeah, this is the actual last example, okay. Well done for getting through it, okay? I really mean that, okay. It's a lovely, lovely chapter. Hope you watch some of the other videos again, okay, because they are, I try to make them entertaining as well, as stuff that you can learn from, okay. But yeah, I think that's it. My job's done, okay. So I'll pack up and I'll be seeing you. that's that. Okay. Yeah, job done. Okay, so just leaves me to, just pack up and leave, I suppose. Let's get it sorted out. That was not supposed to happen. Do I record the video again or do I just walk out? Oh dear. I'll record that again.